Hey, good morning. Let's go ahead and look at what we are going to do this week. If you look at this week's agenda, week 3 agenda, we are doing our digital interactive notebook. We are going to do simplifying expressions on Monday. On Tuesday, Wednesday, and on Thursday, we are going to do multi-step solving equations. And then Friday will be literal equations. So we are going to finish all the slides, well, most of the slides in your journal, and I'm actually going to show you how to get new slides because I am adding to this because we need to add inequalities. So that'll be next week when we add the new slides, or we might add them this week. And so you'll go ahead and have them. So today we are doing slides 17, 18, 19, and 20. And then there is a worksheet on slides, and it says be sure to insert a picture of your work. Wherever you insert a picture of your work, make sure. So then we are going to do a worksheet, and you're going to be sure to insert a picture of your work. And you need to make sure that it's visible, that all the work is visible. It's not going to be hard for me to see. And you can write in your composition book. So we have our composition book, and you're going to write in here anytime you need to take notes or show work. Okay, so let's look at our slides 17, 18, 19. So I need to go down. So it says read definitions and then drag and drop the definitions to where they belong. You can use this quizzes. So I'm going to zoom in because it's really hard to see. Using properties to combine like terms or distribute. So I'm going to give you a little bit of time. I'm going to pause the video, so I want you to pause the video. And you're going to drag and drop, and then we will check this. Okay, pause it now. Play. Okay, so you should have already completed this, so let's check and see how you did. Let me zoom in a little bit. Using properties to combine like terms or distribute. Simplifying the expression. Is that good? Okay. A pair of numbers whose product is 1, the reciprocal of 2/3 is 3/2. A pair of numbers, yeah, reciprocal. Operations that undo each other. Inverse. Less than is used to compare two numbers when the first number is smaller than the second. So it's just less than. Okay. What is that symbol? Greater than or equal to, a number that is the same as or above. So greater than or equal to. A letter used to represent one or more numbers. Variable. The number in front of a variable. Coefficient. A mathematical statement that two expressions are equal. Equation. Greater than is used to compare two numbers when the first number is larger than the second. Greater than. A statement that compares two quantities. Inequality. Less than or equal to, number that is same as or below. Less than or equal to. A term without a variable is a constant term. A mathematical phrase that contains operations, numbers, and or variables. Expression. Okay, I'm going to show you something really cool. Select all these by doing a box around them. And then right click and go to order horizontally and click center. And then it like lines them up really nice. I selected these by drawing a box around them. Then I right-clicked and clicked Align Horizontally. You can click left to make them all in line like that, or center or right. Did y'all see how I did that? Were you able to do it? I like it like that because I like things to look evenly spaced and nice and neat, so that's why I do that. And then if you need to move something down, you can just arrow it down, grab that and arrow down. All right, so now we're on slide 18. If yours is in the wrong order, you need to order, I think this one was the one that was out of order. You need to move the solve fraction decimal equations to slide 26. It was just moved before I sent it to y'all. Okay, so drag and drop the definitions and examples to where they belong. The purple boxes are for extra notes. Okay, so let's look at these. Let's do, oh, that's kind of hard to see, huh? An algebraic expression written with numbers, letters, variables, or both. It's a what? It's just a term. Good. And so an example would be, what are some terms? What do y'all think? Maybe the second one? Okay. And we can move it if we need to, if we find it's not right. The next thing, the number in front of a variable. What is that? Coefficient. All right, so the number in front of the variable. So do we have any here? Examples? I don't think so. I don't see one right now. Okay, the number of a variable holding up the exponent. The number or variable holding up the exponent. Base. The power above the base tells how many times it'll be multiplied. Exponent. Terms that contain the same variable raised to the same exponent. Like terms. Terms that contain different variables raised to different exponents. Okay, so then we need to figure out the what examples go with what. So look at this one, negative 74x and 3x. And then 4x and half x, well, that was bx squared, sorry. 4x squared and half x squared. Those are like terms. Negative 4x squared and 4x. And then 5b and 4a. Those are unlike terms. And then, let's see, 6 to the third and x squared. Those would be, let's put it in here, 6 is the base, 6, and then x is the base. I can make this a little bigger. Okay, let's look at coefficient, the number in front of the variable. Let's use this, the 5x, 7y, 2/3, WZ, and ABC as our example. And so what are the coefficients of each of these? Yeah. 5, comma, 7, comma, 2/3. And what's the coefficient of ABC? Nope, it's 1. Are the coefficients? Yeah, I'm going to make it a little bit bigger. Say what?
How do you say that? Like, how do you...
If there's nothing in front of A, B, C, if there's nothing in front of the variable, then that means it automatically is 1. Okay, and then exponent. Let's use this x squared and then a, b, 4, and 4 squared. Okay, so with exponent, what are our exponents on this one? On the example right here. 2. Well, what is a? If a doesn't have an exponent, they can see 1, and then b is 4, and then 4 squared is 2 are the exponents. And then the last thing I want to write in here about unlike terms, terms that contain different variables raised to different exponents. Put on here, unlike terms cannot be combined. Make that bigger. Did I hurt? Sorry. Only like terms can be combined when adding or subtracting. They must contain the same variable and exponent, or they cannot be combined. I cannot talk today. Okay, so let's go to slide 19. Simplifying expressions. We can do this on paper and then write it and then drag and drop, or you can just drag and drop. Identify like terms. So we're going to use, I guess we're just going to drag and drop here. Add or subtract like terms. So 8n minus 6n. They are like terms because they both have an n. So we just do 8 minus 6. 2n. Okay. 12n plus 12 minus 8. Yeah, we're just going to do this 12 minus 8. If you want to get your scribble tool, you can do like that. Just kind of put a little line underneath, make it a different color, make it a little thicker. And so we know 12 minus 8 can be combined. So we are left with the 12n, and then 12 minus 8 is 4. So 12n. Looks like there's an error, right? That should be plus. So let's change that to plus. I made a mistake, I guess. Oh. So yeah, that should be 12n plus 4, not minus. Six n plus 11 minus 2n. Which ones can I combine? 6n and then minus 2n. So it's still plus, yeah, 6n minus 2n is 4n, and then we still have this 11. 4n plus 11? Number 4, n plus 10 plus 9n minus 3. So I need to combine my n's first. Make sure you take the sign with it. So it'd be n plus 9n. And then I'm going to do another scribble, but do like that underneath. are constants, the ones without the variable. So then I have 10 minus 3. So n plus 9n is 10n, and then 10 minus 3 is 7. So 10n plus 7. Now we have n and minus 5n. And then 4 minus 9. So if we have n and we take 5n away, that'd be 1 minus 5 or 1 plus a negative 5. Different signs, so we subtract. So that'd be 4n. And then 4 minus 9 or 4 plus a negative 9 would be negative 5. Okay, last one. 6n. And then that's 21n. That's 7n, isn't it? I said 6. Number 6. 7n minus 21n. So we know this is going to be the answer. We just want to make sure that I wrote all the correct signs. So 7 minus 21, that would be a negative 14. And then negative 4 plus 7. Different sign, subtract, keep the sign of the larger. So plus 3. Do you have any questions on those? If you need to write them down, that's perfectly fine. Whenever you do your assignment, you will be writing these down. All right, let's go to our last slide of the day. Distributive property. What is the distributive property? Let's look it up. What is the distributive property?
Oh my gosh, mine is screwed up.
What? Oh no.
This was my slide.
Your slide what?
20.
It should be, we can look at it after this. Just work on the slide. We can rearrange as we need. Distributive property is to distribute means to divide something or to give or share part of something. According to the distributive property, multiplying the sum of 2 or more add-ins by the number will give the same result as multiplying each add-in individually by the number, then adding the products together. So when a number is being multiplied by a sum or difference. So an example would be like 5x plus 2. Multiply the number outside the parentheses by everything inside. Then add or subtract. I didn't spell parentheses right. That shouldn't say what a number, it should be when, right? What a number, whatever. And it says, when do you need to use the distributive property? Ooh, should I just have written this? I'm going to drag it. Well, I'm going to copy it and paste it over here. I just copied and pasted this over here, so you don't have to retype it. Just copy and paste it. Control C, Control V. Okay, and then our example, which I wrote that one down, 5x plus 2. So you'd multiply 5 times x, making that 5x. And then you'd multiply 5 times 2, making that plus 10. $5x plus 10 is our example. Okay, so we're distributing on these examples. Drag and drop the color expression beside the equivalent expression. So I have a 2 here. 2 times x plus 6. So that means if you want to do the little scribble, 2 times x, 2 times 6. That'd be 2x plus 12. Do we have that? We do. So complete this drag and drop as your assignment. And then everybody take a step back from the notebook real quick. And let's go back to your classwork so you know what your assignment is for today. It is this Simplifying Expressions worksheet. You are going to follow the path to get to finish. So you're going to start with this. And if you want to use the scribble tool or a shading tool, you could probably just go like, let's see, 5x minus 2y plus 3x. So you do 5x minus 3x is 2x plus 2y. So it'd go over here. But make that darker and thicker. Okay, so you know which way you're going. And you need to take a picture of your work, or you can show your work using Equatio here. But this is your assignment that's due tomorrow before class. Okay. So you're finishing up slide 20 and then doing the assignment. All right, and we are out of time.